In this video, we are going to look at making formaldehyde, CH2O. Some information: formaldehyde was first made in 1859 by Alexander Mikhailovich Butyrov, but not officially identified until 1868 by von Hofmann, who was a German scientist. Formaldehyde is the simplest of the aldehyde group of chemicals. Because so, it's produced in lightning strikes, forest fires, it's found in our cells, it's found in some plants, it's actually found all over the place in very small amounts. It's a colorless, strong-smelling, I would even say pungent gas at room temperature, and it is flammable. Its melting point is negative 92 degrees Celsius, and its boiling point is negative 19 degrees Celsius. In sunlight, it's broken down into carbon monoxide and hydrogen gas through this very simple reaction, which you can see how the carbon monoxide is formed and the hydrogen gas. It's used in resins, plastics, particle board, and to preserve. Not whole body, but bits and pieces in jars, typically. It's known to cause cancer of the upper and nasal respiratory passages, and you can understand why. It's a gas and you're breathing it, etc. So if formaldehyde boils at negative 19 degrees Celsius, how can we use distillation to produce it? Good question. And that is because it binds with methanol to produce a hemiacetal compound or chemical. Hemiacetal binding occurs between an aldehyde or a ketone, both have carbon with double bonded oxygens, and an alcohol, and in this case, it's methanol. It takes one aldehyde, but 3 alcohols to complete the conversion, and I'm going to go over that real quick with you here, and this is very simplistic, but right here is a diagram of the formaldehyde molecule. The O is for oxygens at the top here. You can see the double bonded oxygen right here on the left from the side view. The carbons are the middle black circles, and the hydrogens are the red circles at the bottom here. The alcohol is this R group right here, dash OH, and OH is found on all alcohols. That's what defines them. And that alcohol, and again, in this case, is methanol, will attack the middle carbon right here. And 3 alcohols later, it is converted into what looks like this, where the 2 hydrogens remain in the same place. The OH group from the alcohol is bonded to the carbon directly, and the alcohol itself is now bonded to the oxygen, which was double bonded up here. So you have a completely different molecule when you're done. This configuration allows the formaldehyde to remain in solution longer, so you can get the temperature higher in order that it can be distilled. Now, the word hemiacetal sort of gives itself away, because if you did add another alcohol, as I mentioned, to this group right here, you would end up with an acetal. So the conversion goes from an aldehyde, 3 alcohols later, you have a hemiacetal, and 1 alcohol later, you have an acetal or acetal, as some people name it. So that is why it's named hemiacetal. In this hemiacetal configuration, the boiling point of formaldehyde moves from a negative 19 degrees Celsius up to a positive plus 96 to 98 degrees Celsius, and therefore can be distilled. For our materials, we need potassium dichromate, K2CR2O7, 25 grams, sulfuric acid, 98%, H2SO4, 98 milliliters, and methanol, CH3OH, 40 milliliters. The reaction is 3 methanols plus 1 potassium dichromate plus 4 sulfuric acids will yield 3 formaldehydes plus chromium sulfate plus potassium bisulfate plus 7 waters. In the reaction, the methanol is oxidized while the potassium dichromate is reduced. Because formaldehyde really is a gas in most situations at room temperature, it is mixed with water often, and it can reach a percentage of 37%. At that percentage, it's actually called formalin. For our methods, I got to pull up another board. Sorry. In our methods, we're going to have a round bottom flask with 2 openings. The one on the top will have the addition funnel added to it, and the one on the side will be just a regular funnel. The round bottom flask is going to be in some ice, and it will have a magnetic stirrer. Once these 2 are added right here and it's mixing, we'll have this reaction go. This is before the methanol is added. The potassium dichromate plus the sulfuric acid yields 2 potassium bisulfates, and then chromic acid. And chromic acid is an orange-red color because the chromium ion is in the +6 state. When we open this up and start adding methanol to this will be a red solution. It will turn green, and that's because when we add the methanol, the chromium goes from a +6 to a +3, which is a green color. Once this is mixed for a couple hours, I'm going to disassemble the whole thing, and then I'm going to put it under a distillation setup right here. We'll be using an oil bath because this is a relatively low temperature distillation, and we don't want it over some really hot heat that can drive the temperature up quickly. And once that's set up like so, the formaldehyde will come out of solution around 96 to 98 degrees, and it will begin to drip over here. Once it's made its way into the second round bottom flask, it'll be an ice because formaldehyde does want to evaporate quickly, and the more pure it is, which I'm hoping for, the more likely it is to evaporate. So hopefully this ice keeps it down here. I don't know. I've never done this part of the reaction before, so we'll see what happens. But either way, we'll end up with formaldehyde plus some water will be in there, because if we go back to the original equation, water is produced in the reaction itself. So any formaldehyde mixed in water is called formalin, as I mentioned. The more pure the formaldehyde, which I'm hoping for, hopefully we can capture enough of it to put it in a bottle and see what it looks like, which would be a clear, colorless liquid like we talked about already. So we're done with everything. Let's go make this formaldehyde. 25 grams of potassium dichromate made in a previous video, pre-weighed. 98 milliliters of 98% sulfuric acid, pre-measured. 40 milliliters of pure methanol, pre-measured. I'm going to go over the glassware setup real quick. On the bottom here, we have a 500 milliliter round bottom flask that says sulfuric acid and potassium dichromate are going to be put into very slowly while it's mixing, and with gases escaping through that tube there. And you'll notice that is tied to the top of that other metal bar right there, which will go up the fume hood. So if you can't get this under the fume hood, then divert the gases. On the top here is where the 40 milliliters of methanol will go, and that will drip down also extremely slowly because everything is exothermic. It'll be mixed, obviously, while this is happening. Once that's done mixing, which will take several hours, I'm going to take this 500 milliliter off, which was just a placeholder for the distillation setup here, and I'll be putting this up here while that hole right there is plugged with that and clamped on, just to make sure it's held on strong. And then over here, this is a simple distillation. Once that entire mix of methanol, potassium dichromate, and sulfuric acid is over here, we'll distill it with a hot oil bath. That's why that's there right there, very carefully, until we have our formaldehyde gas with some water come over and will drip down in here. So that's it. It's not really that complicated. It's just this is going to be a slow reaction time. It's going to take a while to do. The first thing we're going to do is add the methanol to the addition funnel, and that's always because if your addition funnel is leaking, you don't want anything in the round bottom flask. All right, going to be adding the stopper. Okay, done. Next, we're adding our sulfuric acid. This came right out of the freezer, so it is definitely cold. As you can see, I also placed ice around the bottom there, because all of this is going to be highly exothermic. And I'm going to turn the stir bar on initially pretty low. Okay, the next step, adding the potassium dichromate. Here's our potassium dichromate, and I'm going to be adding this extremely slowly. I'm just adding the last of the potassium dichromate here. It took me about 45 minutes to add all of it. And we have a very strong oxidizing mix down there. I'm going to keep mixing this until there are no more particles of the potassium dichromate left, and then maybe another 10 minutes just to make sure. I'm not going to video that. That will be quite boring. But once that's done, we'll add the methanol. The other reason we're keeping this cold, of course, is any formaldehyde that's produced early on will stay in the solution due to the colder temperatures and because of the hemiacetal effect. I've let this mix for 2 hours now. I think it's as well mixed as it's going to get, and it's time to start adding the methanol. I'm going to slowly open the stopcock here. We want a slow drip rate. This is also exothermic, and even after it's all done being added, I'm going to mix it for another couple hours. Okay, like one drop every 5 seconds. You can see some of the swirling that's occurring there already. I will be back periodically. With the addition of the methanol, the chromium is now in the +3 state, and that's a green color. So it will remain green from here on out as we reduce the chromium and we oxidize the methanol. Things are going well. There's probably only 5 milliliters left of the methanol. That'll finally drip through, of course. I don't think a lot's going to change here, so I'll just be back when it's done. Everything just dripped through. That took just over an hour to do, so I'm going to turn this off right here. And I'm going to take it apart, at least the top addition funnel here, because it's going to mix for at least another 2 hours. Added some more ice, took off the addition funnel, and Like I said, it's going to mix for a couple hours at least, and then we'll move on to the distillation. 2 hours are up and it's still stirring. You can barely tell in there, but it is. The top is just really smooth. So I'll be taking the placeholder out and putting that in its place. Last we saw, our magical green mix was in here, and I was going to just put this up here and take this one off. And at that point I realized, wow, that's really silly. So I just poured it inside of here. Oh, there's a few drops left in there. It doesn't matter. But I'm not dealing now with having to seal an extra opening, which is just always, you're taking a little bit more chance there. So we're ready to go here. Also of note is that there's oil in there. That's not water, of course. And because this is a relatively low heat situation, these silicone holders will be just fine. You can use vegetable oil in situations like this when you're dealing with lower heat, but mineral oil is preferred because it has a higher boiling temperature, and it also doesn't break down like cooking oil will after some time. I put a thermometer in there to measure the temperature of the oil because obviously that will change first before any vapors do. So we're all set. I'm going to turn this on and I'll be back periodically. The temperature is creeping up nice and slowly there, watching it closely. And on this end, I've got a bowl there with some water. I'll add ice once it actually starts dripping in there. It's not quite at the temperature we need, but we can already see some bubbling there. While trying to reposition the thermometer, I accidentally spilled some of the mineral oil, so we have smoke. Up on top here, we're at 52.4 degrees Celsius. Up and down it looks like a little bit, which this thermometer does, but we're definitely headed towards that 98 degrees Celsius. We're at our target temperature. There's a lot of boiling going on at this point, and I think it's just a matter of minutes now until we start to see our formaldehyde drip through on the other end, and I will show you when that happens. Well, I missed the first drop, but you can see it there on the bottom. That's actually 2 drops, and it's starting to come up 3, 4. We're on our way. I didn't expect the foaming like it is, so got to watch it really close, make sure it doesn't get too high. I turned it down. The oil has quite a bit of heat capacitance, so it's not going to drop as quick as if, it was just on a red hot burner or something. So yeah, just something to note. Well, the foaming has subsided. I turned it down, like I said earlier, and then when I turned it back up, it just didn't foam as much, so I'll take it. And we can see the boiling's going on nicely. The vapors are coming down here, the formaldehyde, and they're ending up in here. But there's a problem, and that is the amount that was in there earlier was more. There's now less in there. So it's evaporating, even in spite of the ice. I don't know what the percentage of the formaldehyde is, but I think it's pretty high because I'm losing it instead of getting more. It was venting through here, I'm guessing. I did smell a slight odor of formaldehyde, but with the fume hood going, which works pretty good, it was very mild, and I didn't even think twice. But I put in this plastic syringe to block it, and it's in there very loosely, so if any pressure builds up, it'll pop right out. And we'll just hope that this evaporation slows down. Plastic syringe was not working, so I took a piece of wood and dipped it into some mineral oil and stuck it in there, and you can see what's leaking out the sides there as the mineral oil kind of pops and does these little bubbles. So yeah, we're losing something. Some of the pressure is natural, but I think out with that is going our formaldehyde, although I think it is helping. There's a little bit more in there than before, so at least it slowed down the evaporation. I hadn't checked this in about 15 minutes, and we are rapidly losing temperature there. It was at around 97 and it's at 70, and it's dropping even though it's bouncing around like crazy. Down here, yeah, it stopped bubbling and boiling, so we're almost done, if not done. On this end, putting that stick up there actually slowed things down quite a bit. Oh, there's a little bit coming through, so maybe I'll let it run for another minute or two. But when it's done, I'm going to take this off quickly and pour the formaldehyde in there and cap it as fast as I can. What might look like boiling is not boiling. What's happening is the solution on the inside of the round bottom flask there is running down the walls, and when it hits the really warm, hot green stuff, it's just causing it to burst into some bubbles there. But it's definitely not boiling. It is time to shut this off, so I'm going to do that and collect our formaldehyde. Alrighty, here's our formaldehyde. There's probably 12 to 15 milliliters in there. That's it. A lot more than that dripped in there. It's unfortunate so much of it ended up evaporating in spite of the ice, but it is what it is. And I can tell from the odor, the pungent odor, this is definitely formaldehyde. And yeah, at least we got some sample there. It's a demonstration video anyways. Hope you enjoyed it.